Good evening, friends. Welcome to Eason Academy. We are discussing about controller programming. The controller programming, session 8. In this session, we're going to discuss about ADC controller. That is analog to digital converter. That's all ADC. Okay, so let us get into the board and continue our discussion. Before I start explaining about analog, somebody has asked, can we reduce the rate to 2? Perfectly right. You have the audio. You sample at any rate. If you do more, let's say instead of 125 microsecond, instead of 2 samples, this timing, it's about, you know that this is your voice is 4 kilohertz. So this one cycle is 250 microsecond. So because 1 by 4 kilohertz is 250 microseconds. If you take 10 samples, understand 10 samples. Then the time becomes 25 microseconds. You will get the very clear sound, much more clarity. Understand? Now we come. This is generally called this 125, 2 samples per second cycle. That is called generally mono. In stereo, you also have what? Sound. So what they do here is, you know that this is your maximum frequency is, audible frequency is 20 kilohertz. Okay, they've added 10% extra. They assume that 22 kilohertz. How much? 20. They given a 10% extra, 22 kilohertz. As per Nyquist theorem, I should put into 2. So 44K samples. That means that, think of it, 44K numbers per second. This is for one voice. In stereo, there are 2 channels. So 44K plus 44K per second. For 1 second, you get 88K. You have to store 88 kilobytes per second. Think of it. Correct. You are perfectly right. That's why I say that. This is what stereo is. Your stereo sound will be very perfect, but it occupies more space. Because you said sample. I do sample 44K per second. The other one, I do sample only 8K per second. You can do much more better. But what they do here is, they have found a method of compression. The compression, they use multiple techniques. Let us assume that this is what my voice. They don't store the full number. They store only the difference. When they do sample, they store only the difference. And also, when we speak, lot of times we have a pause. If you go on, I'll later, maybe the next class, I'll show you that in Audacity, I make a small speech and I see that how it is coming. Then you will know that how exactly, or you can go and see your home also, Audacity. Software is very good. It's an open source. Now, what this MP3 people, the MP3, MP4, these are all compression techniques. They compress the audio to small. These are all one of the nice technologies we work. It's the industry's requirements. Okay. Now let us see how the ADC work. We should not forget that. I explained everything, and if I don't explain about ADC work. Now, I have a DAC. Understand? I have a see here, I have a DAC. Now, I have a counter. The counter is having 8 bits. D0 to D7 comes out. Counter start with, let's assume counter start with 0, 0, 0. And this ADC, DSC is having a signal out. Understand? Now, I want to convert an analog signal. I mean, this is my analog input. This is my analog input that is coming out. I have a device called comparator. I have a device called component called comparator, analog comparator. It will compare the analog one. It's actually op-amp. Plus and minus. You know that this op-amp comparator. I use the op-amp to compare. Now, this comparator output, the output of the comparator is given to the counter to count. Now what happened? Let us say I'm giving a voltage of 3 volts. The 3 voltage is some number. Okay. Now, if I give 0, 0, give them 0 volt. The comparison will be failure. So that guy will count it. Now this guy will increment to 0, 0, 0, 1. Then another voltage. So when you start increasing the voltage, I'll keep on incrementing number. At one point, I get 3 volts. I get what? 3 volts. That time, comparator will stop the counter. So this is called ADC. Yeah, I will after this I'll tell you, because I don't want to miss this. I have 2 responsibilities. One is I have to finish the class. I have to give you the more idea about where we use the ADC and DSC. That's kind. You are right. I don't mind. Even today, time is extended. I'll explain to you that. Don't worry about that. For me, there's no time limit, man. I can take the class any amount of time. It's all you people should not get bored. That's what I have concerned. But this is a very interesting one, because every day you are hearing that sound. See, now what happened? This 8 bits now, D0 to D7. Let me use the other pen. D0 to D7. All the wires are coming out. This is output. Digital output. So do you understand now what is ADC? ADC is nothing but a DAC with a counter. Okay, I keep on counting at one voltage. This voltage and this become the same. That is comes out. But the problem is during this time, the input should not change. Am I right? This input keep on changing means this comparator will not do good. For that, what they do here is they have a switch and they have a capacitor. Understand? There's a switch and a capacitor. This circuit is called, whenever I want a voltage, I will on the switch. And that guy will charge the capacitor for some time. Then I will off the switch. Then this voltage will be compared. So even the input changes, this voltage will be same. So this is called sample and hold circuit. Sample and hold circuit. Why we have to sample? Otherwise, the input will be changing. So the comparator will never become same. That's why I take the sample and keep it here. Capacitor. And this will be these things will happen at very fast time. Nowadays, a counter is given idea. They have some other mechanism. You know what they do? They do call the successive approximation, binary thing and all. They take off of the voltage. Compare. Oh, they take from here 100. Oh, this is become 2.5 volt. This less or more. Then they will compare. They will do that. There are so many methods. Don't worry about that. I'm just giving you the idea only. If you would like to have a functionality of a comparator, go and read the ADC book. I'll explain to you that. Or sometime when you are doing the excellent well, I will explain to you that how these things are working very well. Now my job is to tell you that what is ADC, not inside ADC and all. This is what the concept. Whenever you give an analog input, that is sampled at every time. When I do sampling, as I told you that every 125 microsecond, I on the switch. I sample it. Every how much time? 125 microsecond, I sample it. That voltage comes here. And that becomes the comparator input. Comparator is nothing but an op-amp. So that goes to the comparator input. What it will do, the comparator will do, it will take the DAC output and compare. Now DAC gets the input from the counter. When these two voltages are not matching, I'll give a signal to counter to count more. The counter will be counting from 0, 1, 2 like that. At 1 voltage, the comparator will become equal. When it is equal, this guy will stop. And this guy will give a signal out. Done. This is called done. So you will take the value. You will look for done, then you will take the value. This is the purpose of, or you can call ready. You may use also call ready. You may use any name, it doesn't matter. Or available, whatever it is. That means that it takes some time. This DAC, there are so many methods they use nowadays. But this ADC takes some time to convert from your analog to digital output. Not as fast as DAC. Digital to analog will be faster. But analog to digital will take some time because this guy have to compare various voltages. So there is nothing called the ADC. Actually, ADC uses DAC. This is what so you can compare the sampling time. Right now, we have put it as 125 microsecond. But in the case of stereo, 44 kilohertz. What is 44 kilohertz? I'll tell you the time now. 44 kilohertz means how much? One minute, I use the calculator. 1 by 44,000. Oh, that is 2.2 microseconds. Understand? Sorry, 22 microseconds. That is 22 microseconds. Think of it. Instead of sampling at 125 microseconds, we will sample at 22 microseconds if it is a stereo. So every 22 microseconds, the switch will be on. Then this voltage will come there that time, whatever that time. See, you have a waveform. When I on the switch, whatever voltage, that will be stored in the capacitor. Then switch will become off immediately. The voltage will be there. And this comparator will compare the voltage and be ready. Of course, there can be a small leakage, but before that, it will finish. So that leakage, you can forget it. That's not very, that not people have done a very good, because your op-amp have a huge resistor input. That means that the current will be very less. So the leakage will be very low, and that we can assume that the capacitor will hold the same voltage all the time. The discharging of voltage will not take place. We assume right now. Let us go to the ideal case. Anybody don't understand this, let me know. How AD analog input, this is what there in your board nowadays. Nowadays, what they do here is, what they do now is very clear. They use only one ADC. They take multiple inputs. Let's say 4 input. I have a switch. Understand now? I have a switch. I can on one of them. This is called ADC 0. This is called ADC 1. ADC 2. ADC 3. But I have only one ADC controller. Understand? But I have so many input. I call ADC A0, A1, A2, A3. I have 4 analog inputs. When I want to convert this, I want on the switch. That signal will come here. I will convert it. Then I will off this. I'll on this. That controller will take the data. This you know that. This is called MUX, multiplexer. I take 4 inputs. If you take, for example, your Arduino board, okay, we'll see that. Let us go to the board and see that. 1 minute. Then you will know that what I am talking. Go to the simulator. We'll take the Arduino board. Oh, sorry, I forgot to share. Oh, you hope it's visible now. Am I right? Now you see here, A0, A1, A2, A3, A4, A5. He has 6 channels here. He has 6 channels. See here? 6 channels. A0 to A5. Okay, but that guy has only 1 controller, not 6 controllers. He has only 1 controller. So don't get confused. If by seeing the number, don't think that they have a 6. I'm having only 1 controller, but I'm using all the thing. Let us even see the data sheet. Let us see the data sheet, the block diagram. I open the data sheet and see the block diagram. See now here. Let us see the block diagram. Always try to have a valid data. Otherwise, don't just no dot in the air. See the block diagram here. Okay, you see here, there's only 1 ADC converter. All the 6 inputs are going there. From here, ADC, 6, 7 and everything. Others also going in here. So this guy is having even not only 6, you have even more than that. 6 plus 2, 8 and 2 internal bands. The fact that so many things. If you just go and see that data sheet further, then you'll be able to see that. They will explain here how many channels. See, they've written 8 channel and 10 bit. Do you see that now? 10 bit. What is a 10 bit? That is actually of 8 bit means you get the accuracy of 2 power 8, only 256 division. But whereas when I have a 10 bit, 1000, I have 2 power 10,000 bits. That means that my, I'll show you now that what is the thing. That is very important, the resolution. Now they say that controllers say that not 8 bits, they have 10 bits. If you have a 10 bit, what is the advantage? I'll have 2 power 10. 2 power 10, 1024. samples. Let us assume 1000. That means that if you apply 5 volt divided by 1000, 5 millivolt. So you will be able to, if I have a voltage, if I sample it, the error will be very less. Better resolution, correct. Better resolution means, see, for example, let us assume now. Let us assume that I have 2 power 8. That means 256. Let us assume 250. 250, let us assume. So 5 volt divided by 250. That means that 5000 millivolt divided by 250. Subtract, you get 20 millivolt. 20 millivolt. That means that everything will be increased by 0 volt, 20 volt, 20 millivolt, 40 millivolt. This is 0. This is 1. This is 2. 3 means 60 millivolt. Suppose if I have a sample, I take a voltage that is 15 millivolt. Assuming that my voltage is 15 millivolt, then you're gone because it's not there. There's an error. So if my thing is 10 millivolt, I will take it as a 20 millivolt. So the error will be 10 millivolt. But if you make it this to 10 bits, this becomes 1024, approximately 1000. Then this becomes 1 by 1000, 5 volt divided by 1000 is 5 millivolt. So now what happened? 0 means 0 volt. 5 millivolt means 1. 10 millivolt means 2. 15 millivolt means 3. In between is what? 2.5 millivolt. That means that the worst case error is 2.5 millivolt. In the other case, the worst case error is 10 millivolt. If you do sample 2 power 8, the error is 10 millivolt. In this case, error is 2.5 millivolt. Why I have taken middle is, suppose if you take as a, let us take this, let me write it this. The first case, 0 volt, 20 volt, 40 volt, 60 volt. If you get in here 10 volt, both the sides are same. But if you take here 9 volt, then I will consider this to be a 0. So the error is only 9 millivolt. Sorry, the millivolt. Sorry, I put everything millivolt, not volt. You understand now? That is what happens now. Suppose if this become 13 millivolt, I will take this one. The difference is 7 millivolt. So that's why we take always the middle. When I take 16, understand one thing. When I take 16, think 16 bit, then 2 power 16 is 65,536. Let us approximate to 50,000. Easy to remember. So 5 volt divided by 50,000 is equal to 5 millivolt divided by 50. 5 microseconds divided by 50. 100. So it becomes 100 microseconds. It becomes 100. That means that the error will become only 50 microseconds. Sorry, microvolt. So thank you. So now what happened? You take a mic, take a sound, then electrical, then take the recording. It's a 44 kilohertz, take it, and the microcontroller put it on memory. Then another function take it from the memory and give it to the hard disk controller and store it. Understand? Now, if you do this way, your file size are very big. You go and search the MP3 file and all, and PCM. This format is called wave format. Wave format. This is a very straightforward. I do the sample, I'll store it. This is also called PCM. Pulse code modulation. We are putting the every waveform to the pulse. That's why they call it a PCM. Both are same, wave or PCM. But we use a compression technique that is called your MP3 or MP4. MP4 is for video. MP3 is for audio. By the time what they do, when you do speak, you give so much time pause. When you do pause, I'll be able to do that. I'm not today. Unfortunately, I didn't do with Audacity. I will do it sometime today. I'll give it to you some next week. I'll show you to you next class how that guy is working. You'll be able to really enjoy it. How when you speak, how much time you have pause. The pause is too much of time. Those things will not be recorded. They will say that, oh, so much time is passed. That's enough. They don't waste the hard disk. That you can go and check the now this is available in the Google. You can search wave file MP3 file ratio. That is what the compression ratio. How I'm giving you the great ideas which you don't get it generally on the net. This is a together. It's not. You'll be getting piece by piece as a videos, not together. That I'm trying to explain to you. Okay, so now we have a fairly a good idea about what is ADC and what is DAC. Either you can do two way. You use the what do you call it? The analog input functions given by the routine, or you can start from the scratch. But I always prefer to write it on scratch when you are young. Okay, when you are going to the industry, use the function. But when you are doing it, use with the scratch. They will understand that how the ADC is working. I'll share the program also. I think I have a program for ADC. I'll share it to you. So ADC is nothing but DAC plus counter, nothing more than that. If you could do this, very good. Actually, there is a small project you take in the walkway. Take a temperature sensor. Take a temperature sensor and connect it to the board, Arduino board, and store it on the. We first display it on the 7 segment. Later display it on the dot matrix. Then LCD. Then store it on the SD card. I'll tell you that SD card how to do that when I'm discussing about SPI interface. Correct. Yeah. Analog is the first. Temperature sensor will give you analog. And ADC is now built into the system. Unfortunately, Arduino don't have the DAC. DAC you have to connect it outside. Otherwise ADC is built into the controller itself. That is what I've shown you a few minutes back. How the ADC is there. So it's a very nice thing. Actually, you have to, but don't miss the sequence. LCD, timer, interrupt, then come to ADC. Don't come to the ADC first. You have to know these things because whatever data you are getting ADC should be displayed on LCD. So you should know this. And as I told you that every 125 microseconds, you need to sample. For that, you need to have a timer. And whenever the timer comes, he has to give the interrupt every 125 microseconds. So you should know interrupt. So if you know all the three, then come to the ADC. That'll be very interesting. Don't bypass, don't jump. So these are all when you start programming, then come to me. I'll do a lot of help. They're all very interesting ones, ADC and DAC also. Because every world, all the signals are only, for example, in the last company I worked, we did a sampling of 1 gigahertz. Think of it. What sampling? 1. Yeah, actually, this is a very good question. These type of things are very interesting. That is what the most critical one is, the sensor. All the other things are very easy. How they sense the tank's temperature. That's the trick. That is, they have to send a electromagnetic wave. Then they will get the electromagnetic wave. Based on that, analyzing the return path, how much time it takes. If there's so much of temperature, they know that how much time it takes. When it is having this much heat, then it takes so much of time. I think they will do this. They send the electromagnetic wave and get the feedback. From that, they are sensing it. But this they put about billions of dollars research, man. You don't get it as such very easily. These things. You may try. Somebody may discuss about this in Google. Sorry, in YouTube. But how they detect, nobody will know. If they know that anybody can detect anybody, sir, you don't buy the American tanks. Am I right? You don't the Americans tank destroyer, you will not buy it. But this idea, today, anything, let us say that how they detect the earthquake, how they detect the water is there or not, how they detect tsunami. All these things are based on the sensor. So the very, very important thing is sensor. You should understand about how the sensors are working. But sensor is pure electrical. It does not come here at all. Your heartbeat, how all these things are working, everything is based on sensor. So this is what the issue. So your product will be like this. Your product will be sensor, ADC, microcontroller, microprocessor or whatever it is, then actuator and the control motor, whatever it is. Oh, those things are very simple. Motor control, that you can do that. That's the direction changing and coming fast are all very clear. So those things are all, when you start doing it, let's do a small thing. You build a small robot, small robo, put a path like this, and you have to go from here to here the fastest time. Fastest time. You should know that when to slow down, when to fast, when to slow down, everything. That's all then you will understand the algorithm. You will understand the algorithm, how this robot can move on the line following robot, how it follows the line. Very nice. I know that on this fastest, I say that on the curve, you have to find the fastest time. They are the one who gets. I will keep on changing this. I will give you you don't know what type of path I'm going to give you. I may give you any path in the competition. Your robot, the person whose robot travels faster gets the prize. You should know that when to slow down, You know that on the hill and dot, when they drive the car, somebody will be very experienced, will drive faster. You should know when to apply the brake, when to give the accelerator. That is what exactly here. This is so, that is called algorithm. If you have to get to the stage, practice programming now onwards. Never lose your. See, you know one thing. I've told you already. I started programming at 37. You people are very early. I don't know. You people think that, 25 is a late. I should not start programming. Then you are wasting your time. Nobody can stop you from learning programming. You program anytime. Anytime when you master programming, you have a job opportunity. Super job opportunity. No, I don't know. I don't know how they do that. Ultra age and there's all, you know one thing, they have a sensor nearby. Whenever there's a click and that guy will, on the stump, top of a stump, they have a cameras. You go and watch that stump. The stumps are having a cameras. They get the noise, how it is hitting and all. Nothing. One of my friends told me, when I was working in US, one guy told me, Balaji, you are doing a lot of mistakes in the hardware. You are doing good thinking. Somebody asked me that, what made you to switch to programming? That friend told me, Balaji, you are doing very good thinking. And why you are wasting your time in hardware? In the hardware, people will find only your mistakes. In software, all the mistakes you can correct your while you are doing programming. You switch to software. I thought, okay, why don't we take a chance? I took it, became very successful. Within about 2 weeks, everybody was happy with my programming. I started becoming a very good programmer. Got enough awards. Okay, so these are applications are wide for these things. But how are you going to do? Start doing that. So once you've done LCD, timer, and the interrupt, then come to me. We will discuss about ADC programming. Okay, but I've explained to you that what is ADC, what is DSC. This is a knowledge, no use. No use. You have to develop a skill. You have to develop a skill. Without skill, no use. Don't sit on only knowledge. Keep programming, man. Don't, whoever says, don't bother about anybody. Keep programming, keep programming, keep programming. You will become very successful. Never listen to even your mind. Keep programming. Write on a paper, today I'll sit and do that 1 hour. Don't worry about the results. I'll bet. Okay, so there's nothing called difficulty in programming. You will start enjoying. Somebody is doing it, doing all the moving display and everything. It's all really tough. Generally, if you do that, show it to somebody. I'll release it. Once you give me the surgeon, once you make the moving display of Eastern Academy, I will release it to the video into our group. And if you want, you can share the code also to them after you're done. That people will be very happy that they will be able to do that. That'll be a very nice one. From a scratch, without using any function. Without using any function from scratch. So he has done a good work. That you watch it, you will know that how much time you have to put in to do that one. That'll be very interesting. I'll ask him to share the code to the net, our group. That we can do that actually. Actually, we can do that. Everybody can. I'll tell them, once you share with me, once you become very good code, I'll ask you to share it to the group. So group also can learn it, how to do the coding. That's the advantage of group. Okay. Okay then. Thanks a lot. We'll meet on. Yeah, once you have done, you can share it. That's good. Yeah, that's correct. So we will discuss next week on the more about C programming and motor controller. That will be very interesting. Another interesting one. Okay, thanks a lot.